Hello, everyone, and welcome to today's webinar. Thank you for joining us. We will be taking all questions at the end of the presentation, but please send them in through your Q&A chat box at any time. Let's go ahead and get started. Alex, would you like to take it away?
Sure thing, and thank you all for being here. My name is Alex Fitzsimmons. I am the Deputy Assistant Secretary for Energy Efficiency in the Office of Energy Efficiency and Renewable Energy. Just want to say hello and welcome to you all. I hope you all are doing well and staying safe during this time. I certainly appreciate all of the local government representatives who are on the phone today joining us for this important discussion, including many cities, counties, and other stakeholder groups that work at the local level, and especially that you're joining us under these circumstances to learn about opportunities we may have to partner on technology field validation. So we recognize that these are certainly challenging times, and that your communities and you all are on the front lines. You are often being called upon as first responders. You are providing services to your constituents, all while keeping your family safe. You're helping your local leaders maintain their mission-critical operations. And so we especially thank you for joining in light of this worldwide pandemic and everything going on. And we understand that there's so many demands on your time right now. So we do appreciate your extraordinary efforts. So we're here to talk about technology field validation, which, when we say that, we mean the testing of near commercial ready technologies in a real world setting in the field. And field validation is something that EERE has a history of supporting. You know, for example, our EERE's Building Technologies Office regularly funds field tests of various energy saving technologies that's used to collect data on real world performance and verify that the operational data is working against the data that's collected in the lab. So that's such a critical part of EERE's mission, which is research and development driven, and DOE's mission, but is also focused on de-risking technologies so that they can be adopted by the market. But so while this work is often done at the program level within offices like the Building Technologies Office, it isn't always well coordinated across DOE. And so this is why, in my capacity as the Deputy Assistant Secretary for Energy Efficiency, I asked our Energy Efficiency Technology Offices, which, for those of you who don't know, are the Advanced Manufacturing Office, our Building Technologies Office, the Federal Energy Management Program, and the Weatherization and Intergovernmental Programs Office. So I asked each of those office directors to collaborate on an effort to increase our building sector field validation opportunities, particularly with our public sector partners. And that includes state energy offices, local governments, and federal facilities. So I'm pleased that the offices were able to come together and put forward a strategy, part of which is focused on a certain technology. So we wanted to find where the overlap is between early stage technologies that are almost ready for commercialization and the mission and business needs of our stakeholders, including local governments, and find where that crossover is and where we can work together. So our technology programs and our other programs, WIP and FEMP, got together and they identified 3 technologies in particular. This is not an exhaustive list, but these are the 3 that we identified, at least as a starting point, to get feedback from stakeholders like yourselves about the potential, because we see a lot of potential in these technologies. And we've also heard from a number of you that you're potentially interested and have the capability to validate these technologies in the field. So without further ado, the first technology, and we'll get into these in much more detail on this call today, but just as a brief overview. So the first technology is a building energy management system that we think is suitable for use in smaller office buildings, so in the 50,000 to 100,000 square foot range, which we see as an underserved market. So this technology is a low-cost, cloud-based, open architecture software platform that can both monitor and control HVAC, lighting, and plug loads. So we see that as a promising technology. A second technology we've identified are these thin triple pane windows. So we're talking about windows that use very thin glass, 0.7 millimeters, to increase both thermal performance while lowering installation costs. And as you can imagine, there is potentially a significant number of commercial and residential building sites that would benefit from such a technology that combines both increased thermal performance and a lower cost of installation. So we're excited about that one as well. The third technology is a new micro-injection spray foam insulation system used for rapidly and cost-effectively insulating existing buildings with minimal disruption to the building occupants, which is so important and is so critical to everything we do, because ultimately we're all in the business of making people's lives better. We spend 90 to 95% of our time indoors, even more these days under these circumstances. So we need to make sure that the technologies we're developing are do not sacrifice and in fact even enhance the comfort and productivity of people who work and live inside these buildings. So early tests in a multifamily building for this technology have indicated that you can take a 2-person crew and they can retrofit about 4 units per day. And we found that those retrofitted units can reduce HVAC runtime by at least 25%. So that's an important validation, but we think we can gather even more feedback from you all. So we see this as a potential win-win situation where you can reduce your energy costs. We can get feedback on this technology, and if it works, you can adopt it on a wider scale. So today's call is really focused on addressing the energy needs of local governments. We are here as a resource for you. So we'll dive deeper into the technologies that I just talked about, and we'll describe potential market applications for each of them. And as I mentioned, I've asked the energy efficiency program offices that I oversee to work together to enhance collaboration within the Energy Efficiency and Renewable Energy Office to ensure that your local jurisdiction has the necessary support from the Department of Energy to run field testing and validation that aligns with the mission and business needs of your particular city or county. And so together, I'm really excited about this, and I know that we can help speed up the market adoption of energy-saving technologies that can bolster not just energy affordability, which is a key priority for DOE, but also potentially the energy reliability, resiliency, and help us all have a more prosperous, productive, and comfortable future. So, as I said, we look forward to working with you. Thank you for taking time out of your busy schedules to collaborate with us, and really looking forward to today's webinar. So thank you all for being here. And with that, I'll toss it to Adam. Thank you.
Thank you, Alex. Marissa, if we can go to the next slide. Perfect. So good afternoon, everyone, and welcome again to today's webinar. My name is Adam Gazoo. I'm an advisor in the Weatherization and Intergovernmental Programs Office and serve as EERE's local government lead. Before I briefly run through the agenda for today's webinar and introduce you to our other speakers, I just want to echo the sentiments shared by Alex and offer my thoughts and prayers for you and your colleagues and your communities during this extraordinarily challenging time for our country. We appreciate you joining us this afternoon, given all the pressing priorities in front of you that Alex noted, and we certainly hope you and your family and friends are safe and healthy. With that said, we're excited to talk to you about opportunities for local governments to partner with us in our ongoing effort to enhance field validation opportunities in the public sector. Amy Herone from our Building Technologies Office is going to tell you more about field validation, EERE's field validation efforts, and the benefits of partnering with us on that effort. Following Amy, the bulk of the discussion will be led by technology experts at DOE, our Lawrence Berkeley National Lab, and Building Envelope Materials, and they'll provide more details on the three specific technologies that are noted on the slide, as well as that Alex touched on previously, and I'll let them introduce themselves as we get to that part of the presentation. And then toward the end of our webinar, Amy's going to tell you more about a new funding opportunity and announcement of relevance to local governments. So be sure to stay tuned for more on that. And then before we jump in, just a reminder that as previously noted, the audience lines will be muted for today's webinar. But we encourage you, and you will have the opportunity to submit questions throughout the webinar using the chat feature. And then we will address those at the end of the webinar. And then the webinar will be recorded and slides will be made available for viewing later. So with that, I'll turn it over to Amy Herone.
Great, thanks so much, Adam. And I see we have a couple questions already, so thanks everyone. Don't forget to plug those in as we move forward and you hear more about the specific technologies and the buildings that we're looking for. But first, I just wanted to revisit what Alex introduced a bit about, which is field validation. So today we're talking about technology field validation in real buildings under real dynamic settings with people and operations the way that they normally run in order to better understand how technologies perform in those situations, to understand the cost data that will help us better purchase those technologies and understand all of the operations, maintenance, commissioning, and other scenarios associated with implementing technology in buildings. In our role at the DOE, we, as Alex mentioned, identified these three technologies which are ready for purchase and to be validated in buildings. We will be working with you and other partners to install and collect data on those technologies in buildings, and then sharing the results broadly so that others can benefit. So if, for example, you are not interested or not in a good situation to participate in a technology validation with us, you can keep an eye out for the final report and information about how that validation exercise turned out and learn from it yourself. Next slide, Marissa. Sorry, I didn't let you know to go to the next slide earlier. So as I mentioned, the objectives of field technology validation are to understand how these technologies perform in real occupied operational buildings. And under that scenario, we're looking at energy savings, we're looking at cost savings, we're looking at peak demand reductions and flexibility opportunities. We're making sure that the people in the buildings and the reason the buildings are there are working for them, so there are no comfort implications that would prevent the building from performing in the way that it's supposed to perform. We're looking at maintenance, warranty, operational issues as well. And then with the end result, we're going to share, as I mentioned, we're going to study the applicability of the technology across different kinds of buildings in different places in the country with different kinds of systems and programming. So, you know, you can imagine offices have a lot different programming, so open offices versus enclosed offices, and different setups and sizes. So if there's a technology that's applicable in one office building, would it be applicable in a different one? And we anticipate the performance to be the same or different, and why. So those are some of the objectives. And as we get into the actual validation project, we'll identify any other additional objectives associated with these technologies. So this is just a general overview. Next slide, Marissa, thank you. So as Alex mentioned, this is really the product of a really fun and productive collaboration across the Federal Energy Management Program for the federal sector and the Weatherization and Intergovernmental Program, with otherwise known as WIP, with Adam and our friend Greg from the State Energy Program. We're also doing work with the Advanced Manufacturing Office, which isn't the subject of this webinar, but stay tuned for more on that. And that's all thanks to the Deputy Assistant Secretary of Energy Efficiency, Alex Fitzsimmons, who introduced our call today. So thank you. I'm not going to say the goal again because I think we've covered that pretty well. So you can go to the next slide, Marissa. So as far as the structure of a validation project, we are looking for you to work with us to provide some buildings, because we need those real operational occupied buildings to test out these technologies and understand the implications of people and operations to the technology performance. So we're looking for sites that meet the criteria that are going to be laid out here in a few minutes for you. And at that point, we will work with you to install and collect data and understand the performance. So it can be a long exercise, or it can be a short exercise. And we'll be bringing in the National Labs in order to do that, because they will provide objective evaluation capability. So they're going to collect and analyze and produce the evaluation that we will share broadly with others so that we can understand better how these technologies perform. Next slide. This is the schedule that we're hoping for. Obviously, this is caveated considering most people are working from home right now. A lot of buildings have very unusual load profiles. Travel isn't really being allowed, so there are going to be delays here. But ideally, we would be looking at identifying and negotiating sites for the first couple of months, installation for a couple of months after that. And then depending on the technology, we want to look across different seasons and different climate zones. So the evaluation could be a few months to more than a year. And you can see on this slide, which will be shared after the webinar, that there is a study example for a technology that we validated, Building IQ, through that link. So check it out if you want to see sort of the results of these. You can also look at the Green Proving Ground website, which has a variety of other validation studies published. Finally, just to cover really quickly the benefits to you. So by working with us, it's a little bit lower risk because you'll have access to technical expertise through the national labs and technical assistance in understanding how the validation will work and whether the technology is the right technology for the specific site that you might be interested in trying it. You will get the objective third-party independent evaluation of the technology and get to participate firsthand in the study of that technology if that is something of interest to you, and also understand all of the different trade-offs associated with energy and cost savings with building technologies. We'll help to share the results as well as thank you for your participation in the study. So it is, it's some time on your part to help us solidify the site and participate in project management, understand the study design. But we'll recognize you for that and include your participation in the final results. And then I think I mentioned before, this is, I think, a good way of understanding the trade-offs of building technologies in a real building, how energy savings impact other building energy systems, and also where you can really achieve the best energy savings. And we'll also be taking a really deep look at where the energy in any specific building that we're doing this validation goes. So you might have more insights into how to improve the performance of that building as well as reduce the utility costs. And that is it for me. So I'm gonna turn it over to Armando from Lawrence Berkeley National Lab to talk about our first technology. Thank you so much, Armando. I apologize, I think I went a little bit long. So Armando Casillas from LBNL, take it away.
How's it going? Can everyone hear me fine? Yep. Okay.
Yep.
Okay, perfect. How's it going, everybody? My name is Romano Casillas. I am a scientific engineering associate at Lawrence Berkeley National Laboratory, as Amy just said, and I'm here to present to you an exciting technology called Wisebldg, developed by a company out of Virginia called FEMP Controls. This field of validation project is being conducted by myself along with Jessica Granderson and Guanjing Lin, also at Lawrence Berkeley National Laboratory. Next slide, please. So Wisebldg platform is a central multi-end use building energy management system for small and medium commercial buildings. As Alex mentioned earlier, this is an underserved part of the building stock for a lot of building owners, and it's exciting in that regard. Wisebldg provides single point access across many zones and devices, including things like thermostats, lighting, and smart plugs, along with a customized dashboard and user-friendly interface for building operators and owners that are using this platform. As you can see here on the upper right is the desktop building sort of energy management interface, which shows the thermostat status along with things like set points and scheduling for that given thermostat. On the left, upper left, you see the mobile interface, which shows basic statuses of all of the connected devices that are on the platform. So along with the dashboard, Wisebldg provides optimization and visibility across schedules and set points for all of the devices that are connected to the platform, which then control particular zones in the building. Along with optimization, Wisebldg can also provide things like demand response and overall demand, peak demand control in a building, which then translates to energy and operational costs. FEMP Controls guarantees at least 5% of a whole building energy savings compared to a non-controlled building case delivered through the smart control that I just mentioned. The lower right plots here show a particular system case study that FEMP Controls has provided in the link that's placed at the bottom of the slide. Basically, a building that needed some help in trying to mitigate peak demand costs that were happening in this building, and with some help with widening the set points of this of the thermostat in this building, they were able to basically ride that room temperature over, so the cycling of the compressor in this building wasn't causing that peak demand, and as a result lowered the power demand from 4 kilowatts down all the way to 0.5 kilowatt. So some pretty neat stuff there. Next slide, please. So this is an overview of the cost of the Wisebldg platform. This is an estimate for a 50,000 square foot building. We'd like to stress that the actual cost may vary depending on the number of types and devices and building conditions, and are also somewhat flexible, given that the actual use of Wisebldg will, at least for the evaluation period, only be for 6 months. If the building owner would like to extend that use of the platform beyond the evaluation period, that can be discussed with FEMP Controls separately. So the costs of the platform are twofold. You have the one-time costs, which involve the purchasing of all of the compatible off-the-shelf hardware that can then connect to the Wisebldg platform system. This includes things like Wi-Fi thermostats, IR controllers for split AC systems, lighting controllers, smart plugs, and other things like power meters for sub-metering. So these things will be purchased by the building owner and then installed into the building, along with an installation and commissioning costs that is also a one-time cost, which includes device discovery and customized configuration and data analytics for the power metering. Along with the one-time costs come an annual recurring software and analytical costs. This includes software control, web and mobile access to all the smart devices, as well as optimizing and customizing the interface and dashboard that are provided to the building owners. Along with that is a data analytics cost that includes full cloud access to the data, which will then be able to access by the building owner as well as BEM controls to provide analytics and reporting for all the sensors controlled by the Wisebldg platform. Next slide, please. So this section here describes the criteria that we would like to see in the building, an ideal building that we could run this evaluation effort in. So we're talking to a group of local governments, probably a lot of public sector buildings, office building, small to medium commercial, basically anything from 50,000 square feet all the way to 100,000 square feet. We would like a rooftop unit or an air handling unit in the building that is less than 10 years old and is able to communicate via Wi-Fi thermostat. The current thermostat in the building, we would like it to be manually controlled, sort of an analog thermostat, if that's available. I can explain why a little more later. We would like the building to have the ability to upgrade to the BEM compatible thermostats and lighting controls, as well as have access to a stable Wi-Fi network, or at least allow BEM controls to set up their own Wi-Fi network to then connect the cloud capabilities to the Wisebldg platform. It's nice to have the ability to install smart meters for sub-metering and to provide additional analytics for the Wisebldg platform. As far as data availability, we'd like to have whole building gas usage as well as electric use and peak demand data for the building. This includes hourly or sub-hourly data that's provided by the utility, as well as 12 months of historical baseline electric and gas data, interval and monthly, to establish our baseline for our M&V purposes. Some other considerations, we'd like to stress that the Lawrence Berkeley National Laboratory is available to work with local government agencies to review the portfolio, their portfolios, especially buildings that they think would qualify for this evaluation program. We recognize that a lot of a lot of these buildings have very nuanced, very detailed certain characteristics, and we are here to help and really find a good match for this particular project. The site will need to work with BEM controls to clear things like cybersecurity requirements, and also maintain a high level of engagement to really capture the incremental cost of installing a technology like this. Along with that, we would really like this building to have stable occupancy, operations, and internal loads. All of this to really provide an apples-to-apples comparison of the building before this technology was installed and after the technology was installed. Lastly, we would like documentation of as-built drawings as well as control systems to really understand how the building is operating currently, and then to provide a clear picture of how things changed once the Wisebldg platform was installed. Next slide, please. So this section here details the responsibilities of both the owner and operator. So first is to participate in a 1-year-long study. As Amy mentioned, this timeline is kind of fuzzy right now, but this would include to purchase and install the off-the-shelf open API devices basically meaning the devices that are able to communicate via wirelessly through the internet and provide the BEM controls, Wisebldg platform, things like statuses, and then have the BEM control system then send commands, things like set points and schedules and things like that. So after the host site purchases the hardware, installs it, we run that system for 6 months and then evaluate the performance of the building for those 6 months. After those 6 months, we go in and install the Wisebldg platform and connect all of the devices and provide that centralized control that we highlighted in previous slides. So after that, we run the Wisebldg platform with the building for 6 months and then evaluate the performance of the building in that period. So basically what this does, these 2 6-month periods, it captures the incremental value of the Wisebldg platform. So we would ideally like a building that has very rudimentary, very basic analog control of the buildings, whether that be something like an analog thermostat, manual thermostat, or something like manual lights, or very sort of basic occupancy controlled lighting. And then after that, going in and installing more modern Wi-Fi connectable devices, run that for a certain amount of time, and then going in and installing something like a Wisebldg platform to then tease out how much additional energy and operational costs were given from that. The building operator and user really should remain engaged to properly operate the recommended Wisebldg control sequences, as well as navigate the dashboard and interface that is provided by Wisebldg. It's a good consideration, especially in the small to medium commercial sector, is, this section of the building stock usually doesn't have a building operator, and in that regard, there is a consideration of who is it that's going to be using this platform, and that's something that we would discuss during the recruitment phase of the evaluation project. Along with that, the engagement of the building operators and users helps us qualitatively determine how the Wisebldg platform not only saves energy and saves time, but also affects the operations of the building. That includes both things like occupant comfort, as well as overall building site owner operator satisfaction with the platform itself and overall building operation. Right, I think that's it for me. Thank you so much, and look forward to your questions.
Great, thank you so much, Armando. Next, we are going to talk about new insulation innovations. Actually, I take that back. Insulation. Doug, would you like to take it away from here?
I would, yes, thank you very much. Hi, this is Doug Lamb with Building Envelope Materials, and I'm going to present a technology for a new type of minimally invasive retrofit insulation. This is a technology that was developed over the past 4 years by my company. We have a strategic partnership with a large building materials company called Certainteed, and they've also been involved in the development of the technology. And we also developed this technology through a grant we received from the Department of Energy. The original problem we set up to solve was, how could you get sort of deep energy retrofit savings, which are in the 30 to 40% range, without the invasiveness of a typical deep energy retrofit process. So normally that would involve tearing off siding on a building and putting foam on the outside of the building and resetting windows and all the rest of it. Very expensive, very invasive process. And what we wanted to do was see, could we inject a material into the cavities and get at least close to similar energy savings as through a typical deep energy retrofit. We started out with single family homes. We are now working largely with bigger buildings, particularly buildings that are dominated by walls, simply because walls, if it's a tall building, the energy losses are relatively large through the walls rather than through the ceiling. Next slide, please. So the basic technology is, in concept at least, is really simple. Essentially, all we're doing is drilling a 1/4-inch hole into a wall and injecting a material that's very similar to regular closed cell spray foam. It has exactly the same R value of closed cell spray foam, which is 6.5 per inch. It does have a different blowing agent in it and a different catalyst. Those are both modified in order to allow the material to conform to the interior of the cavity better. But basically, the real trick to this whole technology is a calibration process. And what we do is we inject the material for a known amount of time or a known amount of volume of material into a cavity of known volume. And we use that information to determine a fill rate. And then we modify the injection time, or the amount of material we're injecting into subsequent cavities, based on this fill rate. So, you know, a 7-inch wide cavity would be half the time of a 14-inch wide cavity. That's the basic concept. In addition to the calibration process, we developed through our DOE grant what we call the talking rig. And the talking rig is a dispensing device. It's actually a very simple dispensing device compared to regular spray foam that talks to the technician as the technician is injecting material. And this is really important because the technician needs to know how much material they put into the wall, but it's really hard for them to look at a display. So this thing will count off, uses flow meters to count off the amount of material that's been injected into the wall cavity. So that's one important advantage. The other really important advantage of the talking rig is that when you spray foam an open cavity, you can look at the spray foam and you can see what the quality of the material is. But when you inject material into a wall, you really have no way of knowing how good the material is, whether the material was on ratio or off ratio. So what this thing does is it monitors the ratio of the two components of the material that we're injecting into the wall. And it tells the technician whether they're on ratio or off ratio. And it also tells them if they are off ratio, which, by the way, doesn't happen very often, but if they were off ratio, it actually gives them instructions on how to fix the issue. And there's a valve that they can turn, and it tells them how much to turn that valve to get back on ratio. So those are really the two most important parts of the technology. As far as the advantages go, if you look in the lower left of the slide, you can see what a typical hole looks like. And the hole, you know, it's a 1/4-inch diameter hole. We fill it in about 30 seconds or less with some lightweight spackle. We usually leave it up to the building owner to do any touch-up painting that might be required. Really important aspect of the technology is that we can inject into either empty cavities or under-insulated cavities. And what we mean by under-insulated is a cavity that already has fiberglass insulation in it. And this is actually a really unique aspect of this technology, and it's incredibly important because about 80% of buildings already have some fiberglass insulation in them. So this really expands the market potential for the technology. Third big advantage is that we can validate the fill with an infrared camera. So when these two components of the foam mix together, they generate heat. And because they generate heat, we can see behind the interior panel of the wall and see if there are any voids in what we just filled. We very rarely get voids, but if there was one, we could drill a hole and just shoot a little bit of material in there to fill the void. The last big advantage is related to what's called blowout risk. And what we discovered as we were talking to contractors about this technology is that a lot of them were extremely hesitant to consider anything that involved injecting closed cell foam into wall cavities. And the reason is that they were worried about blowing out the wall or overfilling the wall and causing the drywall or the plaster to buckle out. Without going into a lot of detail, we have a process that we use that it doesn't, you can never totally eliminate that possibility, but we've done somewhere around 7,000 to 10,000 cavities at this point, and we've never had a blowout. So the risk is extremely low. Next slide, please. As far as applications, really huge application for us are brick veneer buildings. The picture on the upper left there is a brick veneer multifamily building that we're doing in downtown Boston for the Boston Housing Authority. It's a 135 unit building. And we have generally found that any sort of masonry or brick veneer is an excellent application for this technology, largely because you can't really use cellulose in an application like that without creating a ton of dust, because you would have to inject cellulose from the inside of the building. So brick veneer, any sort of brick veneer building is a really good application. I mentioned under-insulated single-family, older single-family homes, smaller buildings are excellent applications. Shallow cavities, as you would have in a row house, are also very good applications. These are typically completely uninsulated. So by putting a little bit of insulation in there, you get an enormous benefit, energy savings benefit. These cavities are typically a strapping over concrete block, and we just fill the area. It's about 1 inch deep behind the strapping. Historic structures have been done. My own company didn't do this, the Guggenheim Museum, but this museum was injected by another company. They used a different process, a very extremely invasive process that was done many years ago. But historic structures generally would be an excellent application because you can't change the exterior look of the building. And then, of course, older office buildings. Older office buildings would be very similar to the brick or masonry veneer multifamilies that we've been doing a lot of. Next slide, please. So this is a study that Alex had referenced that we did on an 88-unit apartment building in Providence, Rhode Island. Excuse me, sorry, an alarm just went off on my phone. And so what we did on this in this apartment building is that we monitored 8 units. These were all identical units, and we injected 4 of those units. These were fiberglass. Was a fiberglass insulated building. And what we were monitoring was the HVAC runtime. That's the injected and the uninjected over the course of a winter. And what we discovered was that the injected units had a runtime that was greater than 25% less than the uninjected units. In other words, they basically were saving about 25% energy in the injected units over the uninjected units. And that savings got greater as the temperature dropped. So in other words, when the temperature was below, say, 30 degrees, the savings was somewhere in the 35% range. So that was really exciting information to get. This was validated by a third party. We of course want to get more of these kinds of studies and further do further third-party validation, but this was a nice start. The cost to do this work is $5 to $6 per square foot. It's a pretty rough cost. We'd have to look at each building and drill down on that number, but that's generally where we are. And the time to do this process is pretty quick. As Alex had mentioned, with a 2-person crew, we can do 4 typical apartments per day, and with a 3-person crew, we can do 6 apartments per day. So we can move through a big building like this very, very quickly. Next slide, please. As far as site criteria goes, I mentioned brick or masonry veneer, under insulated fiberglass cavities are very good. Shallow cavities would also be a really good application. Basically, we can inject any building that has a cavity. In practice, the only buildings that have cavities that we don't inject right now are much older buildings, pre-1900 era buildings with mass masonry brick. That's one thing that, and it's not just related to our technology. For any sort of insulation that goes on the inside of mass masonry brick has some risk associated with it. So we're just, at this point in the development, we're just steering clear of those. But basically anything with a cavity after about 1900 we could do. As far as HVAC systems, we prefer electric just because the savings are much greater there, but gas and oil are okay also. We would prefer not to have single pane windows in the building, and that's simply because if there are single pane windows, the chances are the energy loss is so great through the windows that anything we do in the walls wouldn't show huge benefits. And relatively high energy intensity or relatively high energy costs are definitely going to see better results than a building that's already efficient. Location, we can do this in any climate zone. We've done buildings in Florida and south of Florida before. Again, we'll see better results in climate zones 4, 5, and 6, but we can certainly consider any climate zone. Data, we'd like to be able to install sensors, smart meters, sub-metering, all of that sort of thing. And we would like to have monthly utility bills for about 2 years. If there's more, that's even better. And that's it for me. Thank you very much.
Great. Thank you so much, Doug. We are running a little bit late, so we will respond to your questions by email if we don't get to them at the end. And we may go a few minutes over, so please feel free to sign off if you need to. With that, I'm going to introduce Mark LaFrance to talk about Thin Triple Windows. Sorry, we're running late, Mark. Thanks.
Okay. All right. Thanks, Amy. And I can tend to speak fast, but I'll try not to speak too fast, even though we're tight for time. So you can put the next slide, please. My name is Mark LaFrance. I work in the Buildings Technology Office. I mostly do Windows R&D, but I also do field validations for the residential team. And a lot of those are including Windows and other technologies. So many of you might have heard of triple pane windows for the last 30 years. They've been around. They have a very small market share of a couple percent. The typical high performance window today is a double pane low E window, which is significantly better than a single pane window, like 3 times better. But these windows can be, 5 and 6 times better than a single pane window. And the idea of a thin glass is so that it will be the exact same shape and almost the same weight as a double pane window, so that they can fit into the existing window frames, so that window manufacturers do not need to remanufacture the frame. You're just changing the glass package, or what we call an insulated glass unit. And this allows us to have two convective cavities with low E coatings. It allows us to put in Krypton filling. And as you can see from the design here, you can just see from the picture what we're talking about. We're talking about a very thin piece of glass that is not structural. It's just there to give us 2 convective cavities. Next slide, please. So here's we're showing numbers is like R5. Now, if people think of, oh, that's kind of low compared to some of the triple pane windows in residential, that's because when we talk about a commercial window, we're talking about a window that requires a stronger structural requirement in most cases. We've done a lot of work with the thin triple for residential. We have lots of field studies underway as we speak. We have some of the 2 of the largest manufacturers providing the windows for the residential market. And now what we're talking about is working with local partners where we can evaluate commercial windows and where we can apply a thin triple. And mostly we're looking at colder climates, or also looking for potentially mixed climates, or buildings that want to go very low energy consumption, or zero energy buildings. This would be a perfect application. But as far as the structural requirements, As you can see, there's a very large window up to 50 square feet, and we can go up to what we call a commercial rating of 30, which is basically, you know, a low to mid-rise. We're not talking about a very, very high structural requirement. We're not quite there yet for the technology, but there's many applications in the commercial sector that these windows are applicable to. Next slide, please. Okay, one of the big advantages of a triple pane, or in this case, a thin triple pane window, is comfort. So many of you know that if you're in front of a single pane window, it's extremely uncomfortable. Lots of discomfort. And this little chart on the right shows you the difference between a single pane, a double pane, and a triple pane. And so if you go to a triple pane window, now you can utilize the space closer to the window, so you have more efficient utilization of your space. People would definitely don't feel the cold from the radiant feeling of a cold surface. A lot of cases, people think, oh, my windows are very drafty, and you can have leaks in the windows, but a lot of times the window could be completely air sealed, but because of that cold surface, the air is dropping down the surface of the glass, and it's creating a convective loop in the room with a cold surface, and so you do feel a draft because that's the air moving in the room. These windows are significantly more comfortable, so that's one of the biggest advantages. Okay, next slide, please. Okay, and so when we look at a commercial building, we're also thinking about the holistic or a systems level approach. So by putting in a high performance glazing, such as the thin triples, we can eliminate the perimeter zone in many buildings. Obviously, we have to do some energy modeling to prove that, but by eliminating that perimeter zone heating, you're saving a significant amount of economic benefit, and it also allows you to downsize the HVAC system, so you don't need to have as much heating capacity or cooling capacity. So there's really a systems level perspective here that we want to approach. So we're really looking to say, if you want to do a holistic approach, you can put more investment into the facade or to the windows. That allows you to significantly save on the economics with the HVAC to end up with an overall much more economic retrofit than if you just did one measure at a time. So that's really what we're kind of looking towards. And of course, these things also lead to significant peak heating and cooling load reduction. And we know that's another additional benefit that adds value. Next slide, please. Okay, so here I covered a lot of these already, but basically, if you're trying to achieve a significant reduction in energy consumption in your building, then you really need to consider what you can do to upgrade the facade. And this is the next generation of technology that we're moving towards. If looking at the holistic approach where you eliminate the perimeter zone, reduce the HVAC, and when we start talking about installation, you know, a thin triple is almost about the same weight as a double pane window. And one of the problems that people have complained about putting in triple pane windows is that they're heavy and they're bulky and they're hard to install. So this eliminates that problem, makes it just about the same as installing a conventional double pane window. And so there's a lot of system level benefits that really would take into account for doing a thin triple window. Next slide, please. Okay, so this is just basically the requirement. So we're looking for, and I'm not gonna go through this entire list here, but just to touch base on some of the key things. Also, Robert Hart is on the phone today. Him and I, we usually take turns on these presentations. He's the technical lead and expert at Lawrence Berkeley National Laboratory. Today he also was handing off the childcare with his wife because it's a very difficult time for everybody. And he could talk more about this in detail if we need to. But basically, we're looking for a commercial application that would be mostly like a low-rise building. It could be a local municipal building. It could be a library. It could be a fire station. It could be a hospital, for example. There's lots of applications that this would be applicable to, and it could be done in a certain section of a building, so it wouldn't have to be the entire building for evaluation. The ideal application would be one where the building is quite old, it needs significant upgrade, and you're also considering replacing the heating system or the HVAC system, including air conditioning. And by doing that, we could really do a significant case study of the economic benefits that it would provide by doing it as a holistic system with the facade and the HVAC, while providing significant improvements in comfort and the economics behind that. So, of course, there's lots of details on how we monitor the windows. We do, holistic, energy calculations for the consumption, but we also could do localized measurements such as heat flux measurements, and we have different ways of measuring it if it's not the whole building, and whether it's fossil fuel heating or whether it's done by heat pump, it doesn't really matter. The economics are different, obviously, for the project, and we would evaluate that. But the whole idea is to show holistically how you can have a systems level effect. So I think that's all I have for now, and that leaves just a couple minutes for questions. Sorry, the whole thing went so long, but we look forward to answering your questions by email, and maybe, I don't know, Amy, if we can have a few questions before we wrap this up, that'd be great. Thank you.
Okay, Mark, thank you so much. Great job getting that done fast. And we don't have too many questions. I just want to say one of them is about whether public buildings are commercial buildings. Yes, we definitely consider public buildings commercial. And we are looking for a cost share on the validation. So if you're interested, let us know. Marissa, if you can go to the next slide, there is contact information. All these slides will go out to you, so you'll have that. And in the last 2 minutes, I do want to introduce my boss, David Nemzow, the director of the Building Technologies Office, to talk about a $42 million FOA that's coming out. So David, close us out, please. Thank you.
Thanks very much, Amy. I know we're almost out of time, but I am hoping that an incentive of $42 million or even more will keep you on for 2 minutes. The department is planning to do the following. Very formally, our intent to pursue a competitive grant opportunity, what we call a FOA, to invest $42 million, and actually I think it'll end up being quite a bit more later this summer, to develop a demonstration project of connected communities. And I'm not going to spend time right now explaining what they are, except to say that we are being very expansive in how we think about this. We want to invest federal funds to work with local governments, such as yourselves, to work with utilities, with home builders, with commercial building owners and managers, with state governments, with whomever else forms a team to develop communities, and they might be new buildings, they might be existing buildings, they might be residential, as this photo shows, which is in just outside of Birmingham, Alabama, an existing one. They might be existing buildings. They can be all sorts of things. We're very expansive. You can read all this online, or we'll forward it to you. Communities that are highly energy efficient, that are smart buildings, that are connected, that have renewables or storage, highly resilient, but are really built on energy efficiency and smart and connected. So that's the teaser here. We have a request for information on the street. We would love your input, including how you or other local governments could participate. If you go to the next slide, as well as other design elements as we design this, and including those issues I just raised. What's the right kind of team? Are you willing to, the teams need to share data. What's the right way to do that? What different kinds of conditions make sense? And we're going to be funding at least 4 to 6 of these if this comes through as we intend, and maybe more. So we think that's very exciting. We hope you'll participate. We hope dangling money attracts your attention. And if you just go to the last slide, please. And so this will tell you how to engage. So email us or email Amy Harone or Adam Gazoo from this call, and we'd love to get you involved with that, including some of the technologies we just talked about. These connected communities are not, yes, they are research projects, but they're not science projects in the sense that we think they can and should be designed based on technologies that are procurable today, including the ones you heard about today and some other ones, heat pump water heaters, EV charging stations, et cetera, et cetera. So I just want to wrap up today. Again, thank you all for participating today. I hope you're intrigued by these three technologies. You know, we often, as I bet you do, somebody will say to you professionally or your family, hey, what are some new things coming down the pike? What should I be looking forward to? I see these solar panels going on, and that's the thing with energy efficiency technology. We don't always see the progress that we're making, but these three technologies that are coming out there, the Wisebldg software for small and medium-sized buildings, which are 2/3 of the square footage in this country, the non-invasive pinhole insulation, which will save the great disruption that we know is such a barrier to energy efficiency in American homes and offices, and Thin Triple Windows, which, as Mark just said, will look and act, behave to the installer as a regular double-paned window, but are up to 30% more energy efficient, and therefore will be much more cost-effective as they get more mature. So those are three of the exciting technologies. We'd like to work with you to continue to validate them. It's a big country we live in with many different climate zones, sunlight conditions, behavioral conditions, utility prices, building types, building vintage. And so that's why validation is so important to us. And I'll just add as a final note that it's so important and exciting to us to work with the local governments. And you all vary all over the place in terms of your roles and responsibilities, but everywhere in this country, local governments are playing an increasingly important role in the U.S.'s energy future and environmental and, of course, economic development future. So you all know that. I think that's why you're here. But we'd like to engage with you in both your roles, as you heard before, as property owner, as well as leaders in your local community. So thanks for that. Anything else, Amy, or can we let everybody go?
That is it. Thank you so much, everyone. Have a great rest of the day.